In this video, we're going to look at two limits that look a little bit more complicated, but as long as we're able to work with compositions of functions and limit rules, then we should be fine. So, what you might remember is that if the limit, this is going to sound really technical for a little bit, if the limit as x approaches a of g of x, we'll say is b, and the limit as x approaches b of f of x equals L, then this implies that the limit as x approaches a of f of g of x equals L. There's another way to write this. When f of x is continuous at b, we can write this as, we can write that the limit as x approaches a of f of g of x is the same as f of the limit as x approaches a of g of x. And that's pretty much saying what we said above, except with one slight caveat. If we didn't have continuity, the best we could say is that something like, oh, this is going to look really weird. I'm sorry, everybody. Without continuity, that's what this looks like. But continuity, when f of x is continuous, that means that this is the same as f of the limit as x approaches a of g of x. So, yeah, we don't write it like this for a reason because that's confusing. So yeah, we're usually going to be looking at cases where f of x is continuous, and in that case, we are happy to use this rule. All that to say, let's go ahead and use that to take a limit. What that means is that our very first step in taking our limit is going to be to just move the limit inside. So instead of thinking this as the limit as x approaches to a sine of all this, we're going to move the limit inside, so it's sine of the limit as x approaches 2 of pi x squared plus pi x minus 6 over 3x squared minus 6x. And then we would take this limit as normal. So we'll have sine of, let's do some factoring. I will do some quick factoring because I know how this factors. That's going to be pi times x plus 3 times x minus 2 in the numerator over 3x times x minus 2 in the denominator. If you tried to plug in 2, you would get 0 over 0, but thankfully we have some stuff that cancels. So this is really going to be sine of the limit as x approaches 2, that's an x, of pi times x plus 3 over 3x. And that is defined at 2. So we are able to go ahead and simplify that. We can just plug in 2. That will get us sine of pi times 5 in the numerator over 6. And because we are good calculus students, we are going to find the exact value of that. I'm going to look at the unit circle. Pi over 6 is right here. That's pi over 6 radians. And 5 pi over 6 is right here. So I know from my exact value chart that sine of pi over 6 equals 1/2, which means that this is going to have the same sign value because they have the same y coordinate. So this is just going to end up equaling 1/2, and that's our answer. Okay, so as we saw, even though this looked intimidating, all we had to do was move the limit inside the sign, and then we were able to calculate the limit. And we can do the same thing with infinite limits, so let's go ahead and do so. The very first thing we're going to do is move the limit inside. Of pi x squared plus pi x minus 6 over 3x squared minus 6x. Now, the difference is this is an infinite limit, and we have some different techniques for those. Some people will go ahead and use the leading coefficients, which is a good thing to do, but there are times when that doesn't work as well for us. So I like using a little extra step to really convince ourselves that this works. I'm going to multiply. In fact, I'm going to do it up here. I'm going to multiply the numerator and the denominator of this thing by 1 over x squared. What I did is I looked at the highest power, or the lowest highest power. So I look at the highest power of each, that's the degree of each polynomial, and then I'm going to pick the smallest one of whatever those is, and I'm going to divide by that on both the numerator and denominator. So in this case, they both had a degree of 2. Highest power was x squared, so I'm going to multiply by 1 over x squared. So that's going to be the limit of pi plus pi over x plus, I'll just make it plus negative 6 over x squared over 3 minus 6 over x. And what we notice is that all of these things go to 0. That's why we can use that trick that we all know and love of just looking at the leading coefficients, and we'll end up getting sine of pi over 3. And from my exact value chart, I know that that is going to be square root of 3 over 2. So again, it might look intimidating, but as long as we just take that first step of moving the limit inside the sign, it's not a problem.